Hello and welcome to Learn Data. I'm Nilesh and today we'll continue talking about pandas and categories. Today you'll learn how to use operators to get counts, means for categories and how we can handle missing values in categories. Finally, we'll also look at how to handle input-output data when we are working with a dataset that has categories in it. So let's get started in Jupyter Notebook and start coding. Here I've already imported two libraries, NumPy and Pandas, and went ahead and created this series A, which has the elements listed here, 5 of them, and there are 4 categories in that particular dataset. The first thing that we are going to look at today is about operators and how the operators would work. So let's work with that. Now, if we need to get counts of each of the categories, what we can type is a dot value underscore counts open close parenthesis, and this will give us the number of times that particular category value is being repeated in that series. So here for the series A we have M, it appears 2 times and therefore we have 2. P does not appear, so even though it's listed here in categories, it's not there in this particular list that we have. So the unused category is listed here as 0. Now let's go ahead and create a data frame using this particular category and see what we can work with data frame. So df is equal to pd dot data frame, and here we'll create a column called cats, and it will have the value that is currently in series A. And let's go ahead and create another column num for numbers, and here we'll put numbers, say 1, 30, maybe 999, 2 and 40. So now when we look at the data frame df, it looks like this. We have 2 columns, and if we check the data types for dfs, we see that the cats column is a categorical column. Here what we can do is similar to how we had previously used groupby when getting the counts group wise for a simple column which was not converted to a categorical column. Similarly, we can go ahead and use the groupby with categorical column. For example, here we can try df dot groupby, and we can use the column cats for grouping, and if we type mean, then we can get the mean value for each of these categorical variables. So n, we have 35 as the mean, so 40 plus 30 divided by 2, 35. Similarly, we have the values for other variables or categories, and for the category P there is no data, so that's why it comes up as NaN. Now we can go a step further and create another column in this particular data frame, say day, and let's add values here. So Monday, Tuesday, maybe again Monday, again Tuesday, and let's add one Wednesday. So now we have a new data frame where we have 3 columns, out of which if we type the dtypes, only 1 column is a categorical column and the other 2 are regular columns in that data frame. Now if we want to do a group by using 1 categorical column and 1 normal column to look at the values in the num column, we can work similarly as we did before. So df dot group by, here we can type cats for the first column, categorical column, and day for the second column. Now if we type dot mean, we can get the similar to earlier. Here we get the mean values for each of the category, which is n, and then for each day we have these values. So if there is a larger data set, these values would make sense. Here most of them are n because there are no values for that combination in the DataFrame DF. But one important point to remember here with the NANs is that when we are doing a group by, in this case, we do see the unused categories in the output. For example, the category P is never used here, but we do see that category. Okay. Next, what we are going to try and see is using pivot tables, in which you'll see that we do not see the unused categories in the output. So if you try pd.pivot underscore tables, table, and here we use the df column, values is equal to, we are going to use the value day, and then index, we'll use the same cats column, and we'll use the day column. Now when we run this, here we can see that we do not see the category P in anywhere here because it was not used in the data frame, which would have any accompanying values associated with that category in the column num. So if you are confused about how to use a pivot table, I'd suggest looking at our previous video in which we go in much detail as to how to use the pivot tables. So here we are just showing that if we use the group by, we do see the unused categories, and if you do not use the group by, if you use something like a pivot table, then we do not see the categories. Next, let's look at how we can handle missing categories. So missing categories, and here we are going to use the same series that we had earlier, A, and what we will do is we'll introduce a NaN in this series. So we'll remove the O at index 2 and replace it by NaN. Now the series has a missing category in there. If we now look for value counts, what we get is all the 4 categories are listed and in the output, and only the counts for those that are in the series, they are listed. So M appears 2 times, so we have the value 2. Similarly 2 for N. We removed the value O and there was no value P, so those 2 appear as zeros in here. Now if we look at the category codes, so if we type a.cat.codes, here if a particular category is not in that list, so let's go ahead and pull the A as well. Now here we have 1 because the M is there. Then for N we have 0, so it's coded 0, 1, and for NaN the code is -1, as we can see here. At index 2 the code is -1. Further, we can also get a boolean back if we want to check if there are NaNs in the category for that series. So if we type a.isna, we can see that at index 2 we get a true back because there is a NaN present. And we can also write the same command in a different way. We can write pd.isna a, and we get the same output back. So index 2 is true and all others are false. We can also go ahead and replace the NA values as we did with regular series and regular data frames. So to replace the NaN with a specific value, here we'll put the value of O back into the series. So what we need to type is a.fillna, and here if we type O, in place is equal to true. And now if we look at A, we see that at index 2 we have put the value of O back and the NaN is removed from that particular series. Now moving on, let's look at how we can work with input and output. For this, the reason why I'm bringing this up is because when we have a data set or a data frame that has categorical variables in there, so if we have a column that is a category, and if we save that data set to a CSV file on your computer or anywhere, and then pull that file back into your Jupyter notebook, the categories are gone. So the data type category won't exist. We have to go back and convert it into category again. So to check that, we are going to use our regular command df, and in this particular command we can check ahead of time that this has a category column, which is the cats. And now what we are going to do is we are going to add few more categories there to that column. So if we now type df.cats, you can see that it has 4 categories listed. We'll add a couple more, maybe one more. So df cats, and here if we say df cats dot cat dot set underscore categories, and let's add l m n o and p. So we now have additional category there. So now if we look at the df.cats, we can see that we have 5 categories that are listed. If we now go ahead and work with this, we need to import a library called io. So if we want to type import.io, which is right here, and after this we'll create a virtual file. So this would be our virtual CSV file, string.io. And the reason why we are creating this is just to demonstrate that the categories do not exist after we save our dataset to CSV and read it back. So now what we are going to do is save our data frame df to CSV, and the file that we are going to save it to is going to be this virtual file, and we'll set the index is equal to false so we don't get that column when we read the file back. So now we have saved the file. Now we are going to read it in a new data frame df2 by using the command pd.read underscore CSV, and here we are going to use the io string io, and we'll specify the virtual file name dot get value. And once we read this and look at what the value is for df2, we see the columns correctly. That is good. But now if we look at the dtypes for this, we see that the cats column is now converted to objects column, and that's not we had when we saved the file. When we look at the df file, we do see that the cats column was a category column. So what we can do now is convert the cats column back to a categorical column, and using the same methods that we have seen in the past. So this would be df2 cats is equal to df2 cats dot as type. First we need to convert it to category, and then we'll set the values for those categories. So df2 cats, and here again we would type df2 cats. So let me just copy this df2 cats dot cat dot set underscore categories, and I'm gonna go ahead and copy this lmnop that we have typed earlier. So now we have we are going to set the categories for df2 as before. Now if we look at df2.cats, we see that we have the same data set as we had before, and we now have all the 5 categories for that particular column. And that was the main idea behind showing you the input output scenario for while we are working with categories. That was it for this video. I hope in this video you learned how to handle missing categories, how to work with input output conditions for a categorical column, how to get the value counts and mean counts with categorical data. In next video will be the last part for categories, in which we'll look at additional topics that will make us more proficient in using categorical data. Until then, please like, share and subscribe. It helps me stay motivated to create more videos for you all. Thank you, and I'll see you in the next video.